Well, welcome to our lesson on polynomials. A little bit of this will be review for you, but there will also be some new material here. So there you have your learning targets for this lesson and a little bit of vocabulary that we need to cover initially to get through. So the very first thing we need to talk about is what is a term of a polynomial. And a term of a polynomial is just something where you have a product of numbers and variables, and each of these terms is separated by addition or subtraction. The leading term then is the term that has the highest degree. And you might ask, well, what is the degree of a polynomial then? Well, the degree is the highest power on the variable. So down here in this example on your notes here, the highest degree is the variable that has the biggest number exponent. The coefficient is the number in front of a term. It's the number part of a term. And the leading coefficient is the number in front of the leading term. So here we have, in general form, don't let this formula scare you. This is just the general form of a polynomial equation where a sub n is called the leading coefficient. It's the number in front of the x term that has the highest exponent. The degree of the polynomial is n in this case. That's the highest exponent. And then these go in decreasing order. And then the leading term is that very first term that has the highest degree. So I think these make a lot more sense when we just do some examples. In these two examples, it says identify the degree, the leading term, and the leading coefficient of the following polynomials. Well, they are not in standard form. We need to put our polynomials in standard form first before we can identify the degree, leading term, and leading coefficient. So what we want to do is we want to look at this thing and say, well, which variable has the highest exponent? Well, this one doesn't have a variable. The exponent on the variable here is 2, and this one has a variable with an exponent of 3. 3 is the highest exponent on the variable, so that's going to make the degree of this polynomial 3 because of this term. So if I were to put this in standard form, I would put minus 4x cubed first. That's my leading term, has degree 3, and then the leading coefficient will be negative 4. That's the number part with the sign in front of that leading term. So that would be my first term, and then I would go plus 2x squared plus 3. That would be in standard form. Letter B, this one is already in standard form. It's in the highest exponent term first, and then the next highest, and then the third highest. So it's in standard form, so the degree is 5, and that comes from the exponent on t. The leading term is 5t to the 5th. It's the whole term. The leading coefficient also happens to be 5. That's the number in front of the variable t. So that should have probably been some review for you. I think we've covered that before. To add and subtract polynomials, we need to be able to combine like terms. And like terms are terms that have the exact same variable, and it's also raised to the same power, or the same exponent. And there's an example in the paragraph here. 5x squared and negative 2x squared are like terms. They have the same variable to the same power. And we can add those together and get 3x squared. But the terms 3x and 3x squared, these are not like terms. Those do not combine because they have different exponents on the variable. So here's a couple of examples. Excuse me, one adding and one subtracting polynomials. So we can only add the terms that are alike. Well, we can see that 4x cubed doesn't have any other terms to add to it, so it will stay by itself. That'll be the first term, is 4x cubed. Here we have a 12x squared and an 8x squared. Those will combine when we add those to 20x squared. A plus 9x and a minus 5x, those are like terms, and those will add to 4x. And then a minus 21 and a plus 20 will add to give us a minus 1. So the second step here, I've just grouped together the like terms, and then here is our final answer in standard form. You want to make sure that you're putting your answers in standard form as well. Letter B here, same kind of process. We don't have anything to combine with 7x to the 4th or 5x to the 3rd. The thing to be careful of when we're subtracting, this subtraction sign right here, you're going to change every sign inside this parenthesis. So it's like multiplying by negative 1 and adding. So be careful of your signs there. So when we have a minus x squared and then a minus 2x squared, this one actually becomes a plus 2x squared. So we're going to get a positive x squared. So make sure that you're watching that. So check those signs. So here is our final answer on that. All right, to multiply polynomials, a little bit more challenging, but nothing you can't handle. We're going to use the distributive property and then just add what we get together from the distributive property. So the very first thing we're going to do in this slide is we are going to go ahead and multiply everything by 2x over here. We're going to distribute that 2x through the parentheses and multiply each of those three terms on the right by the 2x on the left. So I'm going to go ahead and do that, multiplying 2x by everything there. Then what I'm going to do is I'm going to go ahead and I'm going to multiply everything there by positive 1, and I'm going to write that result as well. Okay, so that's kind of the plan. We're going to distribute the 2x, we're going to distribute the 1, and then we're going to add those products together. So here we go, multiplying the 2x by each term, we end up with 6x cubed minus 2x squared plus 8x. And then multiplying each of these three terms by 1, we get 3x squared minus x plus 4. Now the thing to keep in mind here when you're doing this, it's a good idea. You'll notice that I lined up the terms that are similar vertically so that it's easy to add those together. So when we find the product, we get 6x cubed plus x squared plus 7x plus 4. So that's a good idea for you to go ahead and line those up vertically. It'll make adding your terms easier. Sometimes you'll have, you won't have every term, so you might not have an x term or you might not have an x squared term, so you might want to leave a space there for the terms that are missing. So you should be familiar with what FOIL is. FOIL is a way that we multiply binomials, two binomials together. Remember, it's a binomial because it has two terms. And when we multiply binomials, we use what's called FOIL. It's really just a way of using the distributive property. And FOIL stands for first, outer, inner, last. And that explains how we multiply the binomials. So in this little graphic here, you can see the first terms are AX and CX. The outside terms are AX and D. The inside terms are B and CX. And then the last terms are B and D. So here's an example of using FOIL. Our first terms are 2x and 3x. We want to multiply those together. That would give us a 6x squared. Our outside term in red here is 2x and plus 3, giving us 6x. Our inside term in green here is a negative 10 and a positive 3x. Keep in mind that you're using whatever sign you have to the left of the number. That gives us a minus 30x. And our last term is negative 10 times a positive 3 for a negative 30. And then we need to combine those outer inner terms. Those outer inners will always combine. And so we get 6x squared minus 24x minus 30 as our final answer. So a couple of specific things that you need to be able to do. Sometimes we have binomial products that have special forms, and this is a special form called a perfect square trinomial. So when we square something like a variable plus a number and we're just going to square it, we're going to multiply it by itself. It's a lot faster. Rather than using FOIL, there's actually a formula for doing that. So basically what you're going to do in italics here, it says when a binomial is squared, the result is the first term squared added to double the product of both terms and the last term squared. So all you're going to do to find the product here, rather than using FOIL, you can just square the first term. In this case we'd have x squared. Down here we'd have x squared. Multiply these two terms together. That would give us a times x and double it. So it would be 2ax, and then square the last term, which would be a squared. And that's our formula. So rather than using FOIL, we should be able to do this very quickly. So square the first term in our first example gives us x squared. Multiply x and 5 and we get 5x, but then we have to double that, so that gives us 10x, and then square the last term. So you're going to square, multiply, double, and square. And there's your answer. And you can verify that using FOIL if you like. So again, on the second one here, square the first term gives us x squared. Multiply these together with the sign is a minus 3x and double it, minus 6x, and then square the last term gives us a plus 9. Another special product is the difference of squares, and when we multiply the difference of squares, what happens is you just have to multiply the first terms together and the last terms together. The outside inside always drops out. So here's one. If we multiply the first terms, we get x squared. Multiply the last terms, we get minus 25. Over on the right-hand side, multiplying the first terms, we're going to get 4x squared. Last terms give us minus 9. So it's always a difference of two perfect squares. Here's your lesson check. Work on these, and we'll talk about that in class. See you next time.